Okay, welcome back. Now this is the second example for the multivariate time series lecture taking place this week in the time series analysis course. The example I'm going to use is from the time series package, and the data is called USecon. And let's just look at what this is. It's actually from a textbook, says up there behind my picture. So we have four univariate time series, and what they are, we'll just focus on the first two. First one is seasonal adjusted real US money. Now real money is really correct for inflation, so what can you actually buy? And then your gross national product in normalized to $1982, and then there's discount rate and other things that we won't really pay attention to, for now at least. But let's just make a plot of everything just so that we can see it. And basically what we get here, we're going to focus on the first top two series here. So we have the gross national product, the logarithm of that is kind of a linear increase, and the real money has some fluctuations, and well, whether that is increasing or not, that may depend on other things. So definitely we see that the oscillations increase. So you can see the typical thing to do with financial time series is to often need to do a log transform. So what I'll do is I'll differentiate the GNP and make a log transform of the money. And just do a log, differentiate the log of the GNP and just do the log of M1 at first, and then we'll kind of revisit whether we need to do some differencing here as well. So let's just do that. We got some differencing, give us some NAs that will kind of tease us a little bit later, unless we omit them right now. So replotting now, this is what we got. Now this looks fairly nice. The log of M1, well, yeah, we'll get back to and see what happens when we look at things. Let's look at the autocorrelation function. And here, if we start for the gross up here, we see that you have some nice exponential decay. You have very nothing here, but it's exponential what is there. A little in the other cross term as well, and here we have something that is fairly slowly going down. So we could actually consider just differencing right now, but just for the getting the experience, I will just do it the modeling as is. Like in the other example, I will use the vars package, and I will do the vars select, both with first with a constant, and figure out which one is best. Well, let's use the BIC criteria, the second one here. So this is a number that is our reference. Let's see if we can make it like this. Then we'll do the trend model. So this was our previous best value, having a trend slightly more negative, so that's better. Let's try both. That's not better than minus 1.82. Let's try none. Well, that got close. Minus 1.82, and again, all these models, the order is 2 for the best model, so at least they agree on that. So also across the different criteria, so there's no discussion that order 2, second order model is what we were going for. Now 18267, 18211, so none is better by BAC, and if we check it for AIC, just for experience, minus 1.8443 compared to 844, so none is more negative, so it's smaller. So type none and order 2. Let's fit a model. Now let's look at it, and I forgot to remove the constant. We see it's insignificant here as we expected based on what just before, and The same thing is the case up here, so let's just get rid of it by having type none. That went well, seems. Let's look at the values we got. What we notice is that for the GNP variable, it only depends on the money, or mostly depends on the money, significantly at least, and the money also only depends on the money. Let's just do a plot to see how things works. So this is for the GNP. I mean, if you look at the autocorrelation and the power, I mean, everything looks fine, you can say. And the data series, well, I mean, not much to add. Let's move on to the money that we get here. We get some weird spikes over here around this region here, but again, things looks fairly okay. But there's one thing to note when we look at these parameters. For the real money variable here, if you look at this variable here, the lag 1 and lag 2 dependencies, if you add these two, you get something that is very close to 1, the unit root, which means it's non-stationary. This model, well, it's very close to be so. So beta, this kind of is an indication that we should probably do some differencing here. So, which we kind of knew, but now we just walked through and saw it one more place. So we'll create a new USecon, do NA omit, plot the data. Well, now we look at it. The GNP data looks fairly nice, but the money data here, it looks stationary, but then it seems like something happens around 1980. This will probably cause us some troubles, but we will revert to that. Let's look at the autocorrelation function. Now we got a nice exponential decay there. We got a little bit here in the cross and a little bit there, and exponential thing there as well. So now everything looks, I would say, much more like what we want it to be. So let's do the same variance selection, type constant. Now, since we did one level of differencing for the money, we actually, and that was only, we got a second order model before, and now we go for a first order model because of the unit root that we kind of took out. So this time, so this is not surprisingly that we get 1, that was what I wanted to say. So minus 1.832, let's go for the trend, minus 1.823, so constant is better than trend, let's try both. 826, this was, the first one was 832, so still constant is better. And this one is worse, none is worse, so I actually made a typo here, so it's constant. Let's just double check it. 182 and 183, yeah, so constant is best. So constant is the default, we don't actually have to write anything. We could add just for clarification that type equals constant. Let's look at a summary of this model. Let's scroll up. Now for the GNP, there's a strong dependence on both the previous GNP and on the money lagged one step, and the constant is also significant. Now I'll go for the money. The money depends on itself, but it doesn't depend significantly on GNP. And this constant is not significant. To test all the variance assumptions and stuff like that, we'll use the same function as we used for the Mink-Rosca Muskrat example and just do it all in one go. And this time we see that the Jacques-Barrère is highly significant, skewness is highly significant, kurtosis is highly significant, the conditional heteroscedasticity is highly significant, and there's also some serial correlation which is not highly significant at 0.8. But the first 4 tests show significant. And the reason for this is most likely the contribution that is out here. So for this part it's probably fairly nice. Let's see if we can get residual of deuce 1. Then we could probably just plot these. I didn't do it like that. To make sure that this is a time series like this. Now we get the residuals, and we basically see that there's a large spike over here, and that is kind of what makes all the, at least most of the tests fail. Fail in the sense that we have to reject the null hypothesis that things are behaving nice. But real data, sometimes it's just real data with real problems that we won't solve all of. This is the best model that we have, given what we have tried. There's one thing I would like to get back to, because if we look at the model, the summary here, as I mentioned just before, let's see, maybe I can just fit it. Yeah, it's fine. The gross national product depends on the money, but the money does not depend on the gross national product. Well, what does this mean? Well, could we go for a simpler model? Yes, we could. Because if there are 2 series, but one depends on the other, but the other does not depend on the first one, we could do an input series and just a univariate output series and model that. I won't go through that here, but that is something that you could do in case you wanted to kind of do further development of this. Basically, the added value would be that you could remove one parameter, so it's not going to change the world. So do that if you like for the experience. That's all for now. See you around.